Hi there. Hope you have a fantastic day today. This lesson, I will go through 2022 HSC paper with you. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 31, part A. What is the flowing capacity of the cut shown? So first of all, we know that straight from source to A, so therefore this is a cut. So we have 10. And from here to here, that is from the source to D, so it's straight directly from the source. So this is a cut. So plus 20. And this from D to C is not a cut because it's not from a source. Because if we cut this part here, so that means there's no more flow into D. Okay, keep that in mind. So therefore, this is not a cut. So therefore, the next cut will be C to B. So that is 10. So we add them together, 10 plus 20 plus 10, so 40. So there you go. The flowing capacity of the cut is 40. Part B. By showing a suitable cut on the diagram below, explain why the network's currently maximum flow capacity is less than 40 visitors. So to work this out, there are two ways to do it. One way is we can just do try and error and find the minimum cut. Or we can work out the flowing capacity of each path and then we'll work out from there. So let me just work out by using trial and error. So we already know from here to here, the cut is 40, right? From part A. And if we cut this way, it also give us 40 as well, because 10 plus 20 plus 10. So it's no good. So we're not going to count these two. So then we can cut like this, or we can cut like this. But if we cut like this, we give us 15 here, and we give us 20, so 35. And we have this cut, so that will give us 45, so which is no good because we want to cut that less than 40. So keep that in mind. And if we have this, so we have 15 and we have 10 and then we have 10 here. And this 10 doesn't count because if we cut 10 here, so no more flow into this. So that is 15 plus 10 plus another 10 is 35. So let's see any cut that will give us smaller than 35. So we can cut like this. So that will give us 20 here. And we have 15. So that 35. Another 10. So more than 35. So no good. And we can cut like this as well. So that gives us 40. So therefore, the best one is this cut here. Okay. So this is the best option. So that is 35, right? So we just add them up. So 15, so this is a cut, and this is a cut, and this is a cut as well, and this is not a cut. So that will give me 35 visitors. So therefore, we know that the maximum flow capacity must less than 40. So keep that in mind. So we need to explain why. So let me just write this down. So there you go. Part C. One part is to be increased in capacity so that the overall maximum flow will be 40 visitors at any one time. Which part could be increased by how much? So we need to have a flow capacity of 40. So at the moment, it's 35. So therefore, in order to increase flow capacity, we need to focus on the minimum cut part, okay? So this one here, we need to focus on this, and this is not a cut. So, okay, we can ignore that. So first of all, if you have a look at this, okay, we want to increase to 40. At the moment, we have 35 flow, okay? So we have 35 visitors, if you like, from the source to the sink. Keep that in mind. So to increase this, we can increase this by 5. So that will become 20. See if it works. So we need to note that the inflow must be equal to outflow. Okay, keep that in mind. So if we have 20, because it's 15 plus 5 is 20. So let's say if we can have inflow of 20. So we have 10 here. And then we can actually get 10 to go here as well. Let's have a look. So we have 20 go into D. So we can make 10 go here and then 10 go here. So there you go. So we can increase this and without any drama. Okay. So I can write it down. So we can IE. Yep, IE, the first one, by 5 visitors. Or it could be, let's work it out, see if it from D to E, it works. So let me just clear this first. So now let's say if D, we have 20 inflow, so we can make 10 here and 10 here. Now we want to increase to 5, right? So that is 15. We can make it 15. See if we have inflow, we can make 15 this way. Okay, 15 go here and 5 go here. So, and it still works. Okay, this still give me 10 and this still give me 5. So 15 as well. So therefore, we can increase D to E by 5 as well, if we wish. So, or the path D to E by 5 visitors. Or let's see if we can increase B to C. So from B to C, because this is 10, we can increase 15. See, we have. So if we increase, this is 10. So this one, we can make it 5 here. From where? From 20 go here. So we can make 5 here. And this is 5. And this is 10. So it still works, okay? So that still works. So we can also increase. So instead of this part or this, we can also increase CB. Or we just write C to B by 5 visitor. Okay, so any of these paths will give you the answer. Question 32, part A. Using 2 applications of the trapezoidal rule, calculate the approximate area of the cross sections. So this is the area that is, we need to work it out. So to work this out, so first of all, for trapezoidal rule, we know that A is H over 2 D first plus D last. And we know that the H is from here to here. Okay, so we know that 200 and we divide into 2 sections. So 200 divided by 2 is 100. So now we just need to work out this area because we need to use 2 applications. So let's make this area 1 and this is area 2. So we just need to work out area 1 and then area 2 and we add them up. And let me just put them all together. So area is equal to A1, which is H is the width of the strip, that is 100 over 2. And then D first is this one here, which is 160. And then we add D last, so that is 150. So there you go, that's A1. Then we add A2. So A2, we add H over 2. H is 100 over 2. And bracket, so D first is here, 150. And we add D last, that is this one here. So 250. So there you go. So let me just put on a calculator. So just go. So 100 over 2 is 50. Brackets, 160, we add 150. Close brackets, and we add 50, because it's 100 over 2 is 50. Brackets, 150, we add 250. So there you go, 35,500. So that is 35,500 and square meters. So there you go. Part B. Hence, calculate the area of the lake to the nearest square meters. So we need to work out the lake in this area here. So what I do, I find the area of the whole sections, then we just minus this out. It's easier because we already work out the area of the grass sections, okay? So let me just clear this first. So let me just work out this area and then we add this rectangle first, okay? So area of a semicircle. So area of a semicircle is a half pi r squared. But we know that r is the radius that will give us 100 here, okay? Keep that in mind. So that is 100 square. And we add the area of the rectangle. So the rectangle is this area here. So that is 200 times 250. So 200 times 250. And then what we do, we need to minus this grass area out. So this is this one here. So we just minus 35,500. So that will give me, so it just goes 0.5, that is a half, times pi, times 100 square. We add the rectangle, so 200 times 250, and then we minus 35,500. There you go. There you go. So 30,207.96 and so on. We round up to nearest to square meters. So 30,207. So 30,208 square meters. So there you go. Thank you so much for watching. Bye.